Good afternoon, everyone. Yes, welcome back. We are discussing differential equations and differentiation. So we are going to go forward for it. And before we do that, let us revise a little bit about it. Okay, so we talked about the first principle, and this is the formula as limit of delta x tending to 0, f of x plus delta x minus fx upon delta x. Okay, and this is also known as the first principle. Then we did all these formulas. That is, if I want to find the derivative of x raised to n, it is equal to n x raised to n minus 1. E raised to x will be e raised to x. A raised to x will be a raised to x log a to the base e. Then derivative of a constant is always 0. Then derivative of e raised to ax. Okay, so if derivative of e raised to x is e raised to x, but derivative of e raised to ax will be equal to a into e raised to x. And then derivative of log x is 1 upon x. Always remember that if I have a function in x and if a constant is multiplied by it, then the derivative will be constant into derivative of the function of x. Okay. Then we also did all these rules. Okay. This is the first rule that I talked about right now. That when I multiply by a constant, then you will have the constant into the derivative. Okay. The next rule is for addition and subtraction. Derivative of addition of two functions is the derivative of the first function plus the derivative of the next function. And if it's subtraction, then it will be minus. Then if I have a function which is multiplication of two functions in x, so hx is equal to f of x into g of x, then the derivative is first function into derivative of second plus second function into derivative of first. What happens if my function is a division of two functions? So here hx is a function fx upon gx, then you have in the denominator I will write the second function square, then second function into derivative of first function minus. Okay, remember there is a minus sign here, minus first function into derivative of second. Okay. Then the next one is, which we are going to do today, is hx is equal to f of gx. So that it is a function of another function on x. Then we will do it by putting the inner function gx as equal to z, and then we are going to find the derivative. That example we are going to take today. Okay. So this is the chain rule which says that suppose my function is hx, which is a function of f, which again is a function gx. Okay. If this is the case, then what we should do is we'll put g of x is equal to z. Now what will happen? H of x will be equal to what? F of z, right? But this is x and this is z. I cannot differentiate it directly. So what I do is, now when I have to find h dash x, that is when I want to find the derivative of h, this will be equal to d by dz. Okay, because here see variable is z, so I have to differentiate with z of f of z, and then I will find d of z upon d of x, because z is a function in x. From here you can see z is a function of x. So therefore, whenever I have such a question, then my derivative of z will be equal to d by dz of f of z into dz upon dx. Okay. This you will understand when we take this example. So let us take an example for you to find it. Okay. Normally what we know, let us see this example. We know that log of x, if I want to find the d by dx of log of x, it is 1 upon x, right? I know that is the formula. Now, but here it should be x. But here what is happening is it is 1 plus x square. That means log of a function of x. This means that this is log of a function of x. So this is in the format. This is in the format hx is equal to f of g of x. Okay. This is in this format. So what should be the first step? So step 1 is substitute. What do I substitute? I substitute 1 plus x square is equal to z. I substitute 1 plus x square is equal to z. Now differentiating both sides, differentiate both sides with respect to x, we get, I differentiate both sides with respect to x. What do I get? I get, what is the derivative of 1? 0 plus, what is the derivative of x square? It will be 2x. So it will be 2x is equal to dz upon dx. Okay. So I found that dz upon dx is equal to 2x. So I know that when I have a function like this, what is the formula says? It says that h dash z will be equal to f of z d by dz of f of z into dz upon dx. Okay. So from here I understand I have already got dz upon dx. I have already got dz upon dx. Okay, this I have got. Now I have to find this. Now when I put 1 plus x square is equal to z, my hx, which is equal to log of 1 plus x square, now becomes, this is equal to log of z. Because instead of 1 plus x square, I have put z. Okay, so this is log of z. So now I get d by dz of log of z is similar to d by dx of log of x, isn't it? D by dz of log of x is same as d by dz of log of x, which is equal to 1 upon x. So what will here, what will I get over here? It will be 1 upon z. Okay. Here it will be 1 upon z. So what has happened? I need to find this. So I get that h dash of x will be equal to d by dz of f of z into dz upon dx. D by dz of f of z, I got this as 1 upon z, which is equal to 1 upon z. What is dz by dx? 2x. So it is 2x. Now what do? I resubstitute. Okay. Resubstituting for z, we get, what is z? Z is 1 plus x square. I get h dash of z x is equal to, instead of 1 upon z, what will I write? 1 upon 1 plus x square and 2x. Okay. So the answer is 2x upon 1 plus x square. Okay. Clear? So once you get the question, see whether it's a direct question. If it is a direct question, no problem. If I have differentiate log of x, I know the answer is 1 upon x. Okay. So that time I don't have a problem. Now here I can see that it is differentiate log of 1 plus x square. What is 1 plus x square? 1 plus x square is a function in x. So I will use this, that h of x is equal to f of g of x. That formula differentiation I'm going to use using the chain rule. There I substitute z as the function of x. Then I find hx to be h dash x, that is the differentiation of h will be equal to d by dz of f of z into dz upon dx. Okay. So this is the type of question you may get. Now I have mixed those questions here now, so that we don't do all the same types of sums together, and then what happens when I get a mix of questions, I sometimes am not able to do it. So here what we have done is we have done this where it's directly I could see it's that I have to substitute. Now in this question, again the second question that we are taking up, again here what is happening is, let us see. I know that this is an exponential function. It is a function in terms of e. I know that derivative of e of x is how much? E of x, right? All of you remember? Derivative of okay. When I see this, I remember the formula, and for that you must know your formula. Okay, there's nothing nobody can do about it unless you take that effort. D by dx of e of x is e of x. But here what is happening is, can you see, this is not only x, this is so much more, right? This is so much more. So what do? I'm going to substitute, okay? So I'm going to put let z be equal to ax square plus bx plus c. Okay, now differentiating on both sides, with respect to x, we get dz upon dx to be equal to, what will this be? Ax square, derivative will be a into 2x, derivative of x square will be 2x, plus b into derivative of x will be 1. What will be the derivative of c? 0. Okay, so dz upon dx is 2ax plus b. Okay, 2ax plus b. Now what will happen? My function has now become, is now e raised to z. Okay, why? Because I've substituted the whole thing as e raised to z. So f dash of x will be equal to d by dz of f of z into dz upon dx. Now this will be d by dz of e raised to z into, how much is dz by dx? I know it is 2ax plus b. Now what is d by dz of e raised to z? It will be e raised to z. So this is e raised to z into 2ax plus b. Now e raised to z is how much? Instead of z, I'm going to write this ax square plus bx plus c. So here I have e raised to ax square plus bx plus c into 2ax plus b. So which of these answers is correct? Okay. So my option B is the correct option. See, the answer ends here because this is the C option. Okay. So e raised to ax square plus bx plus c into 2ax plus b. Okay, right? Has everybody understood? Just put in the message whether or not you've understood this question. Yes, Shambhavi, Shiba, Dharmendra, Nikita, good afternoon. Vidya, Neha, great. Omisha, Chandan. Yes, 4B is the answer. Yes, Akashne, very good. Yeah, very nice. Yes, Mansingh, thank you. You liked it? Yes, Priyanka, Bhumika. Now, when you have a function in the form f of xy is equal to 0. See, up till now what happened was I had y on one side and x on the other side. Okay, so whenever I had the function, what did I have? Y is equal to say 2x square plus 3x minus 5. Okay, that type of sum. So here it was very clear. Now suppose I have questions like this. Okay, x square y square plus 3xy plus y is equal to 0, where you cannot directly find y in terms of x. So those are called as implicit functions. Okay, you cannot directly define y in terms of x. Whenever you have this type of equations, you say that the equations are implicit functions. In case of implicit function, so what do? I will take the given function and then I will use the rules of differentiation. So maybe there will be a multiplication, maybe there will be a division. So whatever rules I have for derivative of those, I will use them. I will find the answer and then I will take dy by dx on one side and I will take all the remaining terms on the other side. So remember here, you have to remember two things very importantly is that you will take dy by dx on one side and you will take all the other terms on the right hand side. Okay, so first whatever given question is there, you will use the laws, principles of differentiation, you will use them, find the answer, then you will take all the dy by dx terms together and take all the other terms to the right hand side. If you keep that in mind, then you will be able to solve these. Okay, now let us see this sum. Okay, find dy by dx for x square y square plus 3xy plus y is equal to 0. So here, as you can see, that you can see from here that this is x square into y square, then again here x into y. So what I do is I will simply use all the rules and find the derivative. So my question is x square y square plus 3xy plus y is equal to 0. So here you can see x into y. Here also x into y. So which rule will I use? The multiplication rule. So what do I know? The d by dx of two functions. Suppose I have f into g. Two functions. What will be the derivative? First function into derivative of the second function plus second function into derivative of the first function. So this I'm going to use over here. So what will happen in this term? What will happen? So first I'll show you separately d by dx of x square y square. Now what will be my f here? F will be x square. What will be my g here? G will be y square. So this is my first function. This is my second function. So what is the rule saying? F into g dash. So what is f? F is x square into derivative of y square. Second g is y square. So it will be 2y dy by dx. Okay. Derivative of x square I know is 2x. But here it is y square. So it will be 2y dy by dx. Plus second function. Second function is y square. Y square into derivative of first function. What is first function? X square. What will be its derivative? It will be 2x. So what is here? This is x 2y x square dy by dx plus 2x plus 2x y square. Okay. Now let us take the second term, that is 3xy. So what will be the derivative d by dx? Okay. So what will be the derivative of the second term? D by dx of 3xy. Okay. So this x will be the first term and y will be the second term. So 3x into derivative of the second term. Derivative of second term, derivative of y will be dy by dx. Plus 3y. And derivative of the first term. First term is x. So derivative of x will be 1. Okay. So here first term is equal to x, second term or second function is equal to y. So you can say term or function. So what will I get over here? This is 3x dy by dx plus 3y. Okay. So derivative of this derivative of the function, so d by dx of x square y square plus 3xy plus y is equal to derivative of 0 is 0. Okay. So how much will I get over here? X square y square, I found the derivative as this much. So this is 2x square y dy by dx plus 2xy square. Derivative of 3xy is 3x dy by dx, 3x dy by dx plus 3y. And what will be the derivative of y? This y, it will be plus dy by dx is equal to 0. I will take all the dy by dx terms to one side. So I will get 2x square y. This is the first term. What is the second term? Plus 3y, 3x. What is the third term? dy by dx. So it is plus 1 into dy by dx is equal to how much? I take this 2x square, 2xy square to that side. So it will be minus. Then I take 3y to that side. It will be minus. So this is equal to minus 2xy square minus 3y. Okay. So from here I get dy by dx is equal to minus 2xy square minus 3y upon 2x square y plus 3x plus y. Okay. So this is how you must calculate. So you take one function at a time, solve it properly, take the second part, solve it properly, take the third part, solve it properly, and then you need to add it, and then you all need to do is take dy by dx on the left hand side and take all the other terms on the right hand side. Okay. So let us take the 11th sum now. Dharmendra, in chain rule, what happens is we just simplify it. Okay, why? Because it's a big term. So what I do is I take the big function inside the another function. So I take the function, substitute it, and then what I do is instead of just doing directly dy by dx, I take it as dy by dz into dz by dx. Okay, just let me show it to you. See. Normally, any function I have to find dy by dx, right? But I have substituted for z, so I am writing dy by dz into dz upon dx. So see, dz cancels and you get dy by dx. So mathematically, but here what I have done, I have find the derivative of y with respect to z. And then I found the derivative of z with respect to x. Okay, so that is what we have done. So now let us take the next sum. So here, directly they have not written y is equal to, but you can take it as y is equal to, so that it becomes easy for you to do. Now here, as you can see, So here I will write y is equal to square root of x plus square root of x. Now, as you can see, it is not directly. Had I got only under root of x, I can use it like we did last time. So, square root of x. Suppose I had only square root of x, y is equal to square root of x. Suppose this is the question. So, here what we did, instead of square root, I wrote it as x raised to half. Then I used the formula of x raised to n, derivative formula, and I found it. But here, as you can see, it is square root of x plus another. There is an embedded square root also. So what I do is, I say squaring both sides. Okay, squaring both sides. So how do you know? You know, so many students ask me, मैम कैसे पता लगेगा? अरे आप सम्स करते रहोगे तो आपको धीरे धीरे आइडियाज आने लग जाती कि अच्छा मैं अब ये करूंगा तो मुझे ये easy हो जाएगा. Okay, so what we have to do is we have to simply solve more sums to be able to use these kind of tricks or techniques. So squaring both sides, what will I get? Y square will be equal to square root of x plus square root of x whole square. If I square a square root, what will happen? The square root sign goes away. So what is left with? Y square is equal to x plus square root of x. Okay, y square into. Now I differentiate on both sides with respect to x. What will I get? If I differentiate both sides with respect to x, what will be the derivative of y square? It will be 2y dy by dx. Derivative of y square will be 2y dy by dx. What will be the derivative of x? 1. Last time we have done this. And what will be the derivative of this? This will be equal to 1 by 2 into root x. Okay. You can do this. Okay, shall I show it to you? Okay, let me show it to you. So, I show it here. I'm trying to find out derivative of square root of x. So, d by dx of square root of x is equal to d by dx of x raised to half. Now, d by dx of x raised to n, I know the formula is n into x raised to n minus 1. Okay. So, d by dx of x raised to half, n is half here. So, 1 half into x raised to 1 half minus 1. So, this is 1 half x raised to minus half. I use the indices a raised to minus 1 is equal to 1 upon a. So, I have d by dx of square root of x is equal to 1 upon 2 and 1 upon x raised to half. Okay. So, which is equal to 1 upon 2 root x. Okay. So, that is how I got this 1 upon 2 root x. This is the derivative of root x. Now, I only want dy by dx. So, I will have dy by dx. What will happen to 2y? It will come in the denominator here. So, this is 1 upon 2y into bracket 1 plus 1 upon 2 root x. Now, what is y? I will substitute y is equal to this thing square root of x. So, this is equal to 1 upon 2 into square root of x plus square root of x into bracket 1 plus 1 upon 2 root x. Okay, this is my answer. Do I have this option? Yes. So, here as you can see, C will be the correct option. Okay. So, what you do here, take the function, because there is the square root sign, what I have done, I have squared both sides. So it becomes simple for me, and then when I've squared both sides, I find the derivative, then I take dy by dx onto the left hand side, on all other terms to the right hand side, and I got the answer. Okay, now in the next question, that is question number 48. See here, normally we have, up till now you have only found f dash, okay, or derivative. Here you have to be careful, because here you have to find f dash of 1. Sometimes, you know, I have solved everything and then I see the options, I forget to see this 1, and I say, अरे यहाँ तो कहीं x दिख ही नहीं रहा है. That is because the value of x has to be substituted in as 1 after I have found the derivative, not before. Okay. First I find the derivative and then substitute the value of x as 1. So what happens in this question is, f of x is equal to x square upon e raised to x. This is function in x. This is also a function in x. And there is a division sign. So what will I do? I will use the derivative d by dx of fx upon gx. Okay. What is the rule? Second function. Okay. Second function square. This is second function into derivative of first function plus, okay, just let me use this. Let me put it in terms of g and f only. Okay, so this is equal to g square and g into derivative of first function minus first function into derivative of second. Okay, right? So what is my first function? F is equal to x square. What will be f dash? F dash will be equal to 2x. What is the second function? G is equal to e raised to x. G dash is equal to e raised to x. It is always better, you know, you do this separately and then substitute. Sometimes otherwise, in this question, luckily we don't have difference of signs. Otherwise, when I start substituting directly, I may end up making mistake in the sign. But it is up to you how you do it. Initially, at least try to do it this way, and so that you are very clear about all the formula, and even if you go wrong, you can easily point out from where you made the mistake. Okay. So now d by dx of this will be equal to, so d by dx of x square upon e raised to x is equal to second function square, that is ex square, second function e raised to x into derivative of first function, that is 2x, minus first function into derivative of second. First function is how much? X square into derivative of second function e raised to x. Now this is equal to, I take e raised to x common in the numerator. So this is e raised to x, 2x minus x square upon e raised to x whole square. Okay. So what I can do here, because in the denominator I have 2 e raised to x, so I will cancel this 1 e raised to x with 1. Okay. There will be 1 e raised to x remaining. So what will I have here? This is equal to 2x minus x square upon e raised to x. Normally, questions you have this type of like till here, but here what I have is, they are asking me to find out f dash of 1. This is equal to f dash of x. So f dash of x is this. So here f dash of x is equal to 2x minus x square upon e raised to x. Now I must find f dash of 1 to be equal to 2 into 1 minus 1 whole square. Instead of x, I will substitute as 1 upon e raised to 1. So 2 into 1 is 2, minus 1 square is 1, 2 minus 1 is 1, 1. E raised to 1 is what? E. So answer is 1 upon e. So B will be the correct answer. Clear? Right? So let us go to the 12th sum. Hope you've all understood. Just put it in the chat box. Yes, Priyanka, Sanyam, right. Yeah, very good, Shiba. Yes, Omisha. Yes, Mohammed. Yes, Harshita. Yes, great. Now, let us do the 12th sum. So, what do I do over here? E raised to minus xy minus 4xy is equal to 0. Okay. So, I just find out what is d by dx of xy. D by dx of xy, I will use which rule? I will use the rule d by dx of f into g is equal to first function into derivative of second plus second function into derivative of first. Why is it not? Just a minute. So this is just give me a moment. Pen is not working. Just let me look into it. Okay, just bear with me. So we are doing this sum. So what we have to remember here is we have to remember all the questions that we have all the formulas that we have. So there only we will be able to. Yes. Yes, yes. It's not working. Just give me a moment. Hmm. I'll just close the PPT. Okay, I hope you can see this now. Yeah. Okay, we were on this sum. We've done this. We've done this sum. Now we are doing this sum. Okay. So we have xy. So xy, when I find the derivative of d by dx, this is equal to first function into derivative of second, that is dy by dx, plus second function into derivative of first function. Derivative of x is 1. So d by dx of xy is equal to x dy by dx plus y. Okay. So now what happens here is, so I have e raised to minus xy minus 4xy is equal to 0. Okay. So if I put z is equal to xy, what will happen here is I will get e raised to minus z minus 4z is equal to 0, right? So when I find the derivative, it will be d by dz of e raised to minus z minus 4z. What will be the derivative here? This will be equal to e raised to minus z into minus 1 and minus 4z, it will be minus 4. Okay. So if I find the derivative like this, I will get this as e raised to minus z minus 1 and minus 4. So I have, so what will I get? Dy by dx to be equal to dy by dz substituting, and I will be getting the answer. So this becomes what? I have d by dx as this much. Okay. So what will I get here is e raised to minus xy minus 1 into what will be the derivative? That will be x into dy by dx plus y minus 4 is equal to 0. Right? So this is equal to, so I will have dy by dx is equal to y by x. Right? So this is the way you have to do the sum. Okay. So next sum that we are going to take up is next we are going to understand okay, we did the sum. Now let us take the next one. Okay, we did this. Now we will take this one. X square upon a square minus y square upon a square is equal to 1. So as you can see in the denominator we have a square. So this is x square upon a square minus y square upon a square to be equal to 1. So I will take a square onto the right hand side. So I will have x square minus y square is equal to a square. Now I find the derivatives differentiating on both sides with respect to x. What will I get? Derivative of x square is 2x. Y square will be 2y dy by dx. What will be the derivative of a square? 0. Derivative of a constant is 0. So what will I get? 2y dy by dx is equal to 2x. So the 2 will get cancelled. So I will have dy by dx to be equal to x upon y. Okay, so do I have the option? Yes, I have the option, right? I have the option. So what is the option? Okay, I have not copied down the answer, but here you will get the answer as x upon y. Clear? So simply you have to substitute and you have to find the answer. Next sum. This we have already done. Now the next sum is log of x upon y is equal to x plus y. Okay, so find dy by dx. Log of x upon y okay, so log of x upon y is equal to x plus y. Find dy by dx. Now remember log of m upon n. Remember the division rule for logarithm is log of m minus log of n. You remember that? So applying this over here, this will be on the left hand side. What will I have? It will be log of x minus log of y to be equal to x plus y. Okay, log of x minus log of y is equal to x plus y. So differentiating on both sides with respect to x, what do I get? What is the derivative of log x? 1 upon x. 1 upon x. What is the derivative of log y? 1 upon y dy by dx. 1 upon y dy by dx is equal to, what is the derivative of x? 1. What is the derivative of y? dy by dx. Okay. So now I have to rearrange. I have to take dy by dx onto one side. Okay. So I have, So this dy by dx from here I will take to this side, it will also become minus. So minus dy by dx minus 1 upon y dy by dx is equal to 1. This 1 is on this side, that one, and this 1 upon x I will take it to this side. It will become minus 1 upon x. So if I take this minus sign outside, minus 1 plus 1 upon y dy by dx is equal to 1 minus 1 upon x. So what will be dy by dx? This will be equal to minus 1 minus 1 upon x, 1 minus 1 upon x upon 1 plus 1 upon y. Okay. Now, as you can see, in nowhere the answer is in like this. Okay. In all the options, you will see that the answer is not like this. You have to just rearrange. Whenever it happens, don't get panicked and don't say none of these. This is not none of these. We will simplify this further, and then if it does not match, we will say none of these. Here, let me just find the LCM. What is the LCM here? X. And what is the LCM in the denominator? Y. So this is equal to minus x minus 1 upon x upon y plus 1 upon y. Okay. So this is equal to, now we know that this will be equal to minus y upon x, because this x and y, this will flip the denominator in the denominator when it will come in the numerator. Minus y upon x, what will I have over here? X minus 1 upon 1 plus y. Now see, you can see that this is very similar to this. Okay, this and this are very similar, but here there is no minus sign. But you can see this is 1 minus x. Okay, you can see here this is 1 minus x. This is 1 minus x. And here what do I have? X minus 1. So I can take the minus sign. So this is a very important point. Taking minus sign outside the bracket, in the numerator. Okay, in the numerator, what will I have? This is equal to minus y by x. So if I take this minus sign, so this will be minus y by x, and here it will be minus of 1 minus x upon 1 plus y. Okay. Now this minus into this minus, it will become plus. So what will I have? It is y 1 minus x upon x into 1 plus y, which is same as option A. Okay. So, which is same as option A. So, I have this as the correct option. Okay. Is that understood? How we have to do? And this is the small trick that you need to understand. That's why I put it in red, so that it will remain with you what you are supposed to be doing. Okay. So, just let me check. So let us go to the next sum. Okay. Yes, Bhumika, I will tell you. Don't worry. So we have this. Now let us see the next sum. So as you can see that here what is happening is I have f of xy is equal to x cube plus y cube minus 3axy is equal to 0. x cube plus y cube minus 3axy is equal to 0. Now here you see the term is in x. Here you see the term is in y. But here 3a is constant. So you don't have to worry about a. But here you can see it is x and y. X into y. So you have to use the rule for multiplication. So what does the rule for multiplication say? D by dx of multiplication of two functions is first function into derivative of second plus second function into derivative of first. That we will be using in 3axy. Okay. So differentiating on both sides with respect to x, I get x cube will be 3x square plus y cube will be 3y square dy by dx. Then minus 3a is common. First function into derivative of second function. First function is x into derivative of second function will be dy by dx plus second function y into derivative of first function. Derivative of first function is 1 is equal to 0. So this is equal to 3x square plus 3y square dy by dx. Now minus 3a minus 3ax dy by dx minus 3ay is equal to 0 because this minus sign will multiply into the bracket, right? So as you can see, there is 3 common. So I remove the 3 because all terms contain 3. So dividing the equation by 3, we get x square plus y square dy by dx minus ax dy by dx minus ay is equal to 0. Okay. Now I take all the dy by dx terms to the left hand side and all other terms to the right hand side. Which other terms in dy by dx? Okay, this is one term and this is the other term. Okay. So I will take them into the left hand side and I take the others on the right hand side. So I have y square minus ax dy by dx to be equal to ay minus x square. So I have dy by dx. This y square minus ax, I will take it into the denominator here, is equal to ay minus x square upon y square minus ax. So which of this is the correct answer? Ay minus x square, y square? No. Sorry, not A. B will be the correct answer. Right? So B will be the correct answer. So y square minus ax. Understood? So this is I am taking all the sums from the exercise so that you will have easy. Yes, Priyanka, second. Option B is the correct answer. Yes, Omisha. Very good, very good. Great. Good one. You're doing it fast and so that's really nice. So now let us go to the next sum. So understanding what is parametric equations. Now what happens is that right now we have seen the functions in terms of x and y, right? Y in terms of x. Now what happens is both of these y as well as x are in terms of another variable, say t. So here when both the variables x and y are expressed in terms of a parameter, or which is called as the third variable, the involved equations are called as parametric equations. Okay. So x is also in terms of t, y is also in terms of t, and then there is a relation between x and y. So for the parametric equation, x is equal to ft and y is equal to ht, the differential dy by dx can be written as dy by dt into dt by dx. Okay. So simply you take the equation in x, find the derivative with respect to t. Take the equation in y, find the derivative with respect to t. And what you have to do, you have to just substitute dy by dx to be equal to dy by dt into dt by dx. Here you have to remember that when you are finding the derivative, you find it by dx by dt. But when you are substituting, you have to substitute dt by dx. So here only you have to remember that I have to take the reciprocal. In parametric equation, you only have to remember that much. कि मेरे को याद रखना है कि मुझे उसके बाद reciprocal लिखना है उधर. ठीक है? बस उतनी सी बात आपको याद रखनी. So let us see. So ATQ y upon ATQ. Okay. So let us take this sum. X is equal to AT cube and y is equal to A upon T cube. Okay. Now, as I told you, what will be the first step? So, differentiating both x and y with respect to t. Okay. With respect to t. Whenever the question is given, how do I know it is a parametric equation? I will be able to find out when both x is also given in terms of t and y is also given in terms of t. So what will be my dx by dt? Dx by dt will be equal to a. What is the derivative of t cube? 3t square dt by dx. 3t square. Sorry. Okay. And what will be dx dy by dt? What will be dy by dt? This is equal to a. This is dt d by dt of a t raised to minus 3, because t cube is in the denominator, so it is a t raised to minus 3. What will be the derivative? What is the formula? D by dx of x raised to n. Remember this is equal to n x raised to n minus 1. I am using this formula here. So this will be a into minus 3. N is how much? Minus 3. X raised to minus 3 minus 1. So t minus 3 t it is equal to t raised to minus 3 minus 1. So this is equal to minus 3a t raised to minus 4. Now I know that a raised to minus n is equal to 1 upon a raised to n. Okay, I also know this. I'm going to use it over here. So this equals minus 3a t raised to 4. Okay. So instead of t raised to minus 4, I'm writing it in the denominator as t raised to 4. Now what does the parametric equation say? That dy by dx is equal to dy by dt into dt by dx. Okay. dy by dx is equal to dy by dt into dt by dx. Now how much is dy by dt? minus 3a t raised to 4. So this is minus 3a t raised to 4. Now what is dt by dx? I know that dx by dt is, this is equal to 3a t square. So here I will write it as 1 upon 3a t square. Okay. Because dt by dx is dx by dt ka reciprocal. So this 3 will get cancelled. This a will get cancelled. Answer is equal to minus 1 upon 2 t raised to 6. Minus 1 upon t raised to 6. Okay. I'll just repeat it for you. Take the equation in x, differentiate. Okay. So I got dx by dt. Take the equation in y, find the derivative dy by dt. And then use this formula. Okay. Okay. This is what we need to know. Okay. And this is very, very important. Okay. कि इसको मुझे उल्टा करना है. मेरे पास dx by dt है 3a t square. Okay. From here I have dx by dt as 3a t square. So dt by dx will be equal to 1 upon 3a t square. Okay. That is what I have used here. So this portion is 1 upon 3a t square. So I'll just substitute it like this. Okay. Understood parametric equations? Yes, Varun, very good. Bhumika, it's only 3. No, see, Bhumika, it is t raised to minus 3, right? So it will give you minus 3, right? Because n is how much? Not only 3, it is 3 raised to minus. Okay. So before we move to the next sum, let us take a break for 5 minutes. We'll be back in 5 minutes. What is the time right now? 15:08. So that is, so we will be back in at 13. Okay. So just take a 5 minutes break. Yeah. Yes, Bhumika, please pay attention. You wanted the sum again. So just let me show it to you again. Hemal, you can see the screen? Yeah, thank you. So I have to find this derivative. So I find the derivative. So it is d by dx. Okay, just make it a little thicker. Right. So d by dx of e raised to minus xy minus 4xy is equal to 0. Now I have to find this derivative. So what I do is d by dx of e raised to minus xy. So I know that d by dx of e raised to x is e raised to x. So this will be e raised to minus xy into minus 1. And instead of xy, what I have to find the derivative of xy. So it will be d by dx of xy. Okay. Minus 4 into d by dx of xy is equal to 0 because derivative of 0 is 0. So this will be minus e raised to minus xy. And what is the derivative of xy? It is first function into derivative of second plus second function into derivative of first. So this is x into derivative of first function plus second function into derivative of first. The derivative of x is 1. Minus 4, same thing. X into y dash minus plus y is equal to 0. So I will take all the y dash terms together. So this will be minus e raised to minus xy into x into y dash minus 4 x y dash is equal to, so I will take this to this side. So this is e raised to x minus xy into y minus will become plus 4y is equal to 0. Okay. And then what you will do, you will take the y dash common here. So this is y dash into bracket. I will take the minus sign also common. So this is e raised to minus xy plus 4 is equal to e raised to minus xy into y plus 4y. Okay. Because this is not equal to 0. This is, I have taken it onto the other side. Okay. So what I have done, I have taken all the terms in y dash together and all the other terms I have taken to the right hand side. Okay. From here, what can I find a common? Here, I can take y common. So I have y dash is equal to, so in the, on the right hand side, I have y common. So I have taken y common. E raised to minus xy plus 4 upon, what do I have with y dash? This. So it is minus e raised to minus xy plus 4 into x. So into x. Because here I also have x common. So I have taken the x common. So I have taken x, y dash common outside. So it is e raised to minus xy plus 4. And here also. So you can see that here. So here you can see this term and this term will get cancelled out. So I have minus y by x. So y dash is equal to minus y by x. So A will be the correct answer. Okay. Alternatively, you can put xy to be equal to z and then you can find the equation, the derivative of e raised to minus z minus 4z is equal to 0. You will get the same answer. Okay. Before I ran into technical problems, I was trying to show you both the methods. Okay. So Bhumika, I hope this is clear, the answer. Then let us go to the next one. We have done this. We have done this. This also we have finished. Okay. We have finished this also. Right. We talked about parametric. We've done this one also. So this is also another parametric. I think you will be able to do it. So try them. If you still have any problem with the two sums, the sums are given in the PDF that I have uploaded. Okay, this presentation is already uploaded. So try them. If you still find problems with parametric, I will take it next time. Okay, now coming to logarithmic differentiation. So what happens is sometimes when the sums are there, it is easier to find first the log of the equation. Okay, the equation is complicated in such a way that if I first find the log of the equation and then do the differentiation, then it becomes easier for me. So can we do that? Yes, we can do that provided we take the log on both the sides. Okay, it is not possible that I don't take it on the left and then only take it on the right. No, whatever equation is there, I find the logs on both the sides. Once I get a little simplified version, and then what I do is I find the derivative. Okay. So the process of finding out the derivative by taking logarithm in the first instance is called as logarithmic differentiation. The procedure is convenient to adopt when the function to be differentiated involves a function in its power, or when the function is a product of number of functions. So when do you use it? When it is necessary to simplify. If it is already a simple equation, you don't have to do it. Okay. All these processes are there for you to be able to solve it quicker. So don't complicate it when there is no requirement. No, like here, y is equal to x raised to x. Okay. So step 1. Okay. In such cases, step 1, take logs on both sides. Step 2, differentiate. Okay, clear? So I'm going to take doing this first step, taking logs on both sides. And for that, you cannot skip the chapter on logs. Okay, usko option में मत डालिएगा. So this is log y is equal to log of x raised to x. Now I know that this will be equal to x log a, x log x. Okay, so this is equal to x log x. So this is x log x. Log y is equal to x log x. Now differentiate on both sides with respect to x. What will be the derivative of log y? It will be 1 upon y dy by dx. Okay. This is what? Now this is x log x. Okay, so here I have to use the multiplication rule. So first function into derivative of second function, that derivative of log x is 1 upon x, plus second function log x into derivative of first function. Derivative of first function is x, so a derivative of x is 1. Okay, so what do I get? I keep dy by dx to one side and I take this minus 1 upon y here, so it will be y into bracket and x will get cancelled. Yeah, let me simplify this. So this x cancels with this x. So what is left over there is 1. So I have 1 plus log x. Okay. So dy by dx, in this case, what is y? I will substitute for y. Y is x raised to x. So x raised to x, 1 plus log x. Okay, x raised to x into 1 plus log x. So now let us go to the next sum. So what is the first step? Take logs on both sides. Second step was differentiate. Now in this question, once you look at this, you may want to take logs. But for this question, I've purposely put it over here so that here it is easier to take the squares. Okay, because y is equal to square root of function upon function. So instead of trying to find this, what I do is I square both sides. Okay, in this question, squaring both sides. Okay, remember in mathematics, you have to do the action for both sides. Squaring both sides. What will happen? Y will become square, y square, and squaring of the square root sign will remove the square root sign. So this will be 1 minus x upon 1 plus x. Okay. Now as you can see, this is a derivative of first function divided by second function. So division rule will apply over here. So differentiating on both sides and using d by dx of f upon g to be equal to second function square, second function into derivative of first function minus first function into derivative of second function. Okay, so what do I get here? Derivative of y square will be equal to 2y dy by dx is equal to second function, that is 1 plus x the whole square, first function, second function 1 plus x, derivative of first function 1 minus x will give me minus 1, and first function is 1 minus x into derivative of second function will give me 1, because derivative of 1 plus x is 0 plus 1. Okay. So what do I have here? I have 2y dy by dx is equal to 1 minus 1 minus x minus 1 plus x upon 1 plus x whole square. Okay. So what will happen? This minus x will cancel with minus plus x. So what is left here is, so I have dy by dx is equal to 1 upon 2y into minus 2 upon 1 plus x square. Okay, so this 2 will get cancelled with this 2, and what will I have is 1 upon y minus 1 upon y 1 plus x square. Okay, and then you may even substitute for y. Clear? So you can do it in this way. Now coming to a very interesting thing which is called as higher order differentials. Now this is going to tell you why we need derivatives, why we need to learn derivatives integration. So what happens is that this has very practical application. You have an equation and then you found out f dash, that is the derivative. If you find the derivative of this derivative, then we say it is higher order differentials. Okay. So f dash, then I find f double dash, I can find f triple dash, so I can go on. Okay, so long as I can find a derivative. What is the meaning of this is that we say that if after the second derivative, so what I do, I find the first derivative, I equate that derivative to 0, I solve it and I find the values of x. Those values of x are called as critical points. This means that something is happening in this equation at those points. Okay. Now, when I find the second derivative, and substitute these values of x that I had found out, that is the critical values, if the value is positive, if after substitution the value comes to positive, I say I have a minima. If I have a negative value, I say it is a maxima. Is that clear? I repeat, I find the higher order differentials in the, say that I have f, I find out f dash. Now I take this f dash, I equate it to 0. I find the critical values. Once I found those critical values, what do? I take those values and then I find the second differential. Okay, I find the second differential. What is second differential? Differential of the first differential. Okay, अभी जो differential निकाला था उसको एक और बार differentiate किया, उसको second differential बोलते हैं. Now, if I put the values of the critical values that I've obtained into the second differential, and if the value comes to positive, I've got a minimum. If the value comes to negative, I've got a maxima. Where do I use it? I use it in costing. When I'm manufacturing a product, what do I want to do? I want to minimize the cost, right? And what do I want to maximize? I want to maximize the profit. Okay. Whenever I'm manufacturing something and selling it, what do I want to do? I would like to increase my profit. So can I keep on increasing my selling price? No, I have competition, right? So when I have competition, what will happen? I can't go on increasing the sale price. So what I do, I need to that time cut down on my cost, or I will need to manufacture in such a way so that at a particular point, my costs are minimum. Okay, so for all this, I use the concept of maxima and minima. Okay, I'll just show it to you with this example. But remember that if it is positive, we have a minimum. Now I have f to be equal to x raised to 4 plus 5x cube plus 2x square plus 9. Okay. Or let me take it this instead of this. Okay, just let me take this as minus sign. Okay, just let me take it as minus. So this is minus. Okay, x raised to 4 plus 5x cube minus 2x square plus 9. So what will be f dash? 4x cube plus 15x square minus 4x plus 0. Okay, because derivative of 9 is 0. Now what do I do? Equate f dash to 0. So I have 4x cube minus 15x square minus 4x is equal to 0. What I can take? X common, x into 4x square minus 15x, plus 15x minus 4 to be equal to 0. What does this give me? This gives me either x is 0 or 4x square minus 15x, 4x square minus 15x plus 15x minus 4 is equal to 0. This is a quadratic equation. I can solve this. So how much will I get? 16 and minus 1. Okay. So I have x plus 4 x minus plus 4 and 4x minus 1, okay, is equal to 0. Okay. So if I solve this quadratic, I should get this. So x is equal to minus 4 or x is equal to 1 by 4. Now I have to check whether or not I have a maxima or a minima here. So what do I do is, I will substitute here. So I will find second differential, f dash. So f dash of what? I have to find the derivative of this 4x cube plus 15x minus 4x. So this is f double dash. So of this will give me how much? So what will this be here? Derivative of 4x cube will be 12x square plus 30x minus 4. Okay. Now let me put x as minus 4. F double dash of minus 4. What will be the value? 12 into minus 4 square plus 30 into minus 4 and minus 4. How much is this equal to? 4 square is 16. 16 into 12, answer is 192, and 192 minus 120 minus 4. Answer is 68. And let me see f double dash of 1 by 4. So this will be 12 into 1 by 4 whole square plus 30 into 1 by 4 minus 4. So 12 divided by 16.75. Okay. Then 30 divided by 4, 7.5 minus 4, 3.5 plus this. Okay. So you can solve this. Now what I want to show you here is, just a minute. If you put it in a graph, okay, I just want to show you. See, if I substitute all this in a graph, okay, and if I plot it, so if I put in the values of x, so I've taken from minus 5, 4.5, so like this. So this is the graph that I get. And over here, as you can see that x raised to x equal to minus 4, I can see that the value is a minima. Okay. So this is how you are supposed to be doing it. So if you even plot it on a graph, you will see that you get a minima over there. And if you don't need to plot it, you can even do it finding the differential and you can find out. Okay. So this is just for your understanding. You will not be needing a graph. I'm just trying to show you that you can do it in this way also. Okay. So you can find out that you have a minima there. Now the first question is that in word problem, how do I get problems in differential? So they are saying find the gradient of the curve at x is equal to 0. See, now in all these sums you will see that you're finding that at a particular value. So what we are doing here is gradient means what? I have to find y dash. Okay, gradient means I have to find the derivative, first derivative. So I have y which is equal to 2x cube minus 3x square minus 12x plus 8. So what will I do here? So I find y dash. What will be the derivative? X cube will be 3x square, 3 into 2, so this is 6x square minus 3, the derivative of x square is 2x. 2x into 3 is 6x minus 12. Okay. So this. But what do I have to do? I have to find y dash at x is equal to 0. I want the gradient. Gradient means the slope. Slope at x is equal to 0. This is equal to 6 into 0 minus 6 into 0 minus 12. This is not 1.2. By mistake, there is a... Okay. This is simply 12. Okay, 6 into 0 minus 6 into 0 into this. So answer is minus 12. Minus 12 means what? The line is like this. Okay. Simply like this. So answer is A. Understood? Just let me check. Okay, I will be taking 1 or 2 questions more, and then I would like to take the problems on doubt clearing session that you needed. Jaspreet, I hope you have understood now. Yes, Piyush. Yes, Bhumika, right. Yes, Harshita, Priyanka. Right? Okay. Now the gradient of the curve is given like this. At the point 3, 2 is minus 2 by 3. Find the values of P and Q. Okay. So y minus okay, y minus xy plus 2px plus 3qy is equal to 0. What I have to do is, I have to see at the point 3, 2. Okay, so this 3, 2 means what? This is the value of x and this is the value of y. So substituting x to be equal to 3 and y to be equal to 2, I get 2 minus 6, 2 into 3 is 6, plus 6p plus 6y is equal to 0. Okay, y is 2 minus xy will be 3 into 2, 6 plus 2p into 3. So that is 6p. 3 into y is 2. So 6y is equal to 0. So I have minus 4 plus 6p plus 6y is equal to 0, or 6p plus not p, 6q. Okay, this is q, not, because y is 2, na? So we have q here. Okay, so this is 6q is equal to 0. So this is also 6q equal to 0. So 6q is equal to 4. This minus 4, when I take it to this side, it becomes plus 4. So if I divide this equation by 2, dividing by 2, I have 3p plus 3q is equal to 2. This is my first equation. Now let me differentiate this equation with respect to x. So what will I get? I get, because why do I need to differentiate? Because they have given in the question the gradient of the curve at this point is those. So derivative of this function, given function, will be dy by dx minus xy. So it is a multiplication. So first function into derivative of second plus second function into derivative of first. Minus. Because there is a minus sign, I have put in the bracket. First function into derivative of second plus second function into derivative of first. First function is x, so derivative will be y. So only 1. Okay. Plus 2px. So derivative of 2px will be 2p. And derivative of y, 3qy will be plus 3q dy by dx is equal to 0. So I take all the dy by dx together. So dy by dx into 1 minus x plus 3q. Okay. So this is my first term, this is my second term, then this is my third term. Is equal to, so what I get, minus y going this side becomes y plus y minus 2p. Okay, minus y becomes plus y, plus 2 becomes this. So dy by dx is equal to 2 by 3. Okay, dy by dx is 2 by 3 because they've given it in the question, right? It is 2 by 3, yeah, minus 2 by 3. Okay. So this is minus 2 by 3 is equal to y minus 2p upon 1 minus x plus 3q. And what are the points? What is x? X is equal to 3 and y is equal to 2. So I have minus 2 by 3 is equal to y is 2. Na? So 2 minus 2p upon 1 minus 3 plus 3q. And I have to cross multiply and form the second equation. So what will happen? I will find the second equation in P and Q. Okay. So once I get the second equation, I have the first equation and I can solve it and find the values of P and Q. Okay. This is one method of doing it. The second, that is the shortcut method I'm giving you, is that use all these options, substitute in the equation, see for which option the equation is solved for the values of P and Q, and then you will have to see whether the gradient comes to minus 2 and 3. Minus 2 by 3. Okay. So both these methods you can do. This is simply basic thing that you need to understand in this is, whenever you have such questions, is that you take the equation, substitute the values of x and y that are given to you, you will get the first equation in the P and Q. Second, you differentiate and then put in the value of the slope and the values of x and y, you will get the second equation in x and in P and Q. Use the first equation and second equations, use simultaneous equations and solve it. Okay. This question number 8 is also similar. Okay. Now what I want to tell you is cost functions. Okay. I was just telling you about the higher order derivatives and then we were talking about this also. See, in costing, whenever I want to price a product, what happens is, in costing there are two types of costs. One is called as the fixed cost and one is called as a variable cost. Fixed cost is, suppose I want to manufacture pens. So what will happen? I will first have to make a factory. I have to buy the machinery. So all those things, buying of machinery, buying of the or building, making of the building, those are all my fixed costs. Those I have incurred one time. And then I have what is called as the variable cost. So in variable cost, what happens is that I will, for each pen that I manufacture, there are certain things that I need. I need raw material, I need labor, overheads. So all those things come in the variable cost. So whenever you have a cost function, it consists of two parts, variable cost and fixed cost. Now, when I want to find the average cost, It is total cost divided by number of units manufactured. That is my average cost. Okay. Then there is a concept of marginal cost. Marginal cost is the amount of expenditure that I need to manufacture only one more unit. Okay. So one more unit which I require to manufacture, what is the cost I will incur? Okay. So here, as you can see in this, I have average cost. Okay. Average cost, which is total cost. Average cost is equal to total cost upon X. Okay. So they will give you a cost function. All you need to do is take the cost function divided by X, you will get the average cost. Now, average variable cost will take the variable cost divided by X. Average fixed cost will be fixed cost divided by X. Okay. And as I said, marginal cost will be dC by dx. C is the cost function that is given. So that cost function, you will find the derivative that will give you your marginal cost. Okay. So to increase profits of a company, the company may decide to increase its production. Now, once you increase production, what will happen? Your cost is also going to increase because your variable cost per manufacturing is going to increase. So you have to see whether or not the increase in profits are matched. Okay, I cannot have only increase in profit and there is no increase in cost. No, I will have to see. So what is the point or what is the number of units I need to manufacture so that I get maximum profits? Why that may happen is, suppose I want to manufacture more, then what happens? I need to give overtime to my worker. So there instead of increase in profits, my profit may decrease. Why? Because overtime maybe I have to pay more, a larger amount than the normal, at a bigger rate than the normal rate at which I pay my employees. Okay. So let me show it to you by an example. Okay, so this is the example from the book. The cost function of a company is given by Cx is equal to 100x minus 8x square plus x cube upon 3. Find the level of output at which marginal cost is minimum and average cost is minimum. Okay. Okay, this is my cost function. So marginal cost is saying what? Finding the derivative. Marginal cost says dC by dx. So what will be the derivative? This is 100 minus 8x square. Derivative will be, the derivative of x square is 2x. 2x into 8 is 16x. And this will be, x cube will be 3x square. So 3x square upon 3. Now this is 100 minus 16x plus x square. Now at this, what do I do? Equate to 0. So I have x square minus 16x plus 100 is equal to 0. So what are the factors? 25 and 9, 25, 4 the, okay, no, 25, 4, I will not get 16. So what will be the factors here? 100 is 100 into 1 or it is 50 into 2. Then you will have 25 into 4. You have 20 into 5. Okay. 100 minus 16 plus x square. Minus 16 plus or minus 64 minus 4 AC minus 4. It's a question correct? Just let me check. Okay. minus 8x square okay. So upon twice e, 12 upon 2, not a. So upon 2. So I have to find square root of 60. So 60 square root 7.7. So that is 8. So minus 16 plus 8 minus b, minus minus plus b. So this is minus minus plus b, 16 square. Okay. So that is why 16 into 16 to 56. So let me find the, because there are no direct roots here. So I will have to find it, this thing. So I have a normal quadratic equation. This is x square minus 16x plus 100 is equal to 0, right? So what do I get? I have b to be equal to minus 16, a to be equal to 1 and c to be equal to 100, right? So I have, the roots will be minus b, so this is 16 plus or minus square root of b square, that is 256 minus 4 into 1 into 100. Okay. So I can upon twice a, so upon 2. Now I can use this and then I can find the roots. Now what happens here is that I have this marginal costing as 100 minus 16x plus x square. Okay, plus x square. Now I find, to find the same, so marginal costing, I find another derivative of this. So this is equal to minus 16 plus 2x. Okay, derivative of 100 is 0. Derivative of minus 16 will be minus 6. 16x will be minus 16 plus x square, it will be 2x. So what I get? 2x is equal to 16 and x is equal to 8. So at this point I have to find. Okay. So once I know this, I will be able to find the cost at x is equal to 8. So what is at x is equal to 8? What is the cost at x is equal to 8? It will be 100 into 8 minus 8 into 8 square plus 8 cube upon 3. Okay, so you will find the value. Then what else is asked over here? They are asking you to find the average average cost minima. Okay, so average cost minima is, that is 100x minus 8x square. Cost is equal to 100x minus 8x square minus x cube upon plus x cube upon 3, right? Plus x cube upon 3. Okay. Now average cost is what? Cost upon x. Average cost will be cost upon x. So this will be 100 x upon x. So you will have 100 minus 8x square upon x will be 8x and x cube upon 3 will be x square upon 3. X square upon 3. Now when I find the derivative, okay, so what do? I find the derivative, differentiate both sides. Okay, and I find 100. So derivative of 100 will be 0 minus 8 plus 2x square upon 3. Okay. Okay. So this way, and I have X at, what is the value of X? X I found it as 8. At 8, my costing is minimum. Okay. So this is the way you have to solve this sum. Then revenue function is there. Revenue is what? Sales minus cost, sales. So revenue will be what is the price into number of units I am manufacturing. That will be my revenue. And then marginal revenue will be what is the change in the revenue that I earn when I sell one more unit. Okay. Then profit margin will be revenue minus cost. So this is one sum. I'll take it up next time also. So let me go to the doubt solving that I want to take up with you. Okay, this is page 5.30, 15 sum. Okay, this is the doubt solving for permutation and combination. See, the number of ways in which 9 things can be divided into 3. It's not twice, okay? This is a printing mistake, into 3 groups containing 2, 3 and 4 things. Now, I have this group 1. This is G2. And this is G3. How many people do I need here? I need 2 people here. How many people are available? Or things. Okay, so there are 9 things available. I need to choose 2 things to put in group 1. So this is 9C2. Okay. Now what happens? I have put 2 people in this group 1. 2 things in this group 1. How many things are left? 7. 9 minus 2, 7. So how many people things do I need in group 2? 3 things. So 7C3. After I have put 3 people over here, 3 things over here, how many things are left? 4. Okay. And how many things do I need to put in group 3? 4. So that is 4C1. Okay. Group 1 has to contain 2 objects. So I have 9 objects. From the 9, I can choose 2 objects. How do I do that? 9C 2 ways. Then after that, how many things am I left with? 7. So 7C3, because in the next group, I need to have 3 objects. And in the next, what will happen? 4 things are remaining. In the last group, I need to put only 4. Now 9C2 is 9 factorial upon 7 factorial into 2 factorial into 7 factorial upon 4 factorial into 3 factorial into 4C4. So 4 factorial upon 0 factorial into 4 factorial, because 4C4 is remaining 4 things are there and I have to put them in the group. Now this is how much? This is 9 into 8 upon 2 into 7 into 6 into 5 upon 6 into 1. Because this 4 factorial and 4 factorial will get cancelled, you get 1. Because you can choose 4 things from 4 things only in one way, right? So that is why the answer is 1 for this one. So this is 2 4s are, the 6 gets cancelled. 8, 4, 7 and 5. So, no, sorry, 9. 9 into 4 into 7 into 5. The answer is 1260. Okay. So, this is your correct answer. Okay. Let us quickly move to the next sum. Okay. 16 sum. n-1 PR. Okay. So this is n-1 PR plus R into this is equal to n-1 factorial upon n-1 minus R factorial plus R into n-1 factorial upon n-1 minus R plus 1. Okay, be very careful with this. Okay, here it becomes plus. Here it becomes plus. Why? Because this is n-1 minus of R minus 1. Now minus R and minus into minus will become plus 1. Okay, is that clear? Why I got the plus 1 here? Because if I don't write the plus 1, I will never be able to solve this sum. Now in the numerator, I can take n-1 common, right? So n-1 is common. Now here what happens is this is n minus R minus 1 factorial. R into n minus 1. I have to just rearrange. Okay. Now this is n minus 1 minus R plus 1. So this minus 1 and this plus 1 get cancelled. So I am left with n minus R factorial. Now, very important is n minus R factorial can be written as n minus R into n minus R minus 1 factorial. How do I get this? Because you remember, I can write n factorial as n into n minus 1 factorial. Remember? N into n minus 1 factorial. So same way over here, n minus R to n minus R minus 1 factorial. Okay. So here first term n minus 1 factorial upon n minus R minus 1 factorial plus R into n minus 1 factorial upon, instead of n minus R factorial, I am going to write this way. This is equal to n minus R into n minus R minus 1 factorial. Okay. Now from the numerator, I will take out n minus 1 factorial common. From the denominator, I will take out n minus R minus 1 factorial common. So I have n minus 1 factorial upon n minus R minus 1 factorial common. What is left here? 1 plus here it is left R upon n minus R. Okay. N minus 1 factorial I have taken out. N minus R minus 1 also I have taken out. Now what will this be? This will be n minus 1 factorial upon n minus R minus 1 factorial. This will become n minus R plus R. What will happen? Minus R plus R will get cancelled. What is left with is n into n minus 1 factorial upon n minus R minus 1 factorial, right? So what into n minus R into n minus R. So from here I know n factorial is n into n minus 1 factorial. वही है numerator में. So this is nothing but n factorial. And in the denominator n minus r minus 1 factorial into n minus r, which is nothing but this thing which I have written in orange. So this is nothing but n minus r factorial. What is n factorial upon n minus r factorial? This is nothing but npr, right? So option. Okay, so option C is the correct option. See, up till here, students they get confused over here. Remember, if for this I am using this, and for the denominator I am using this. Clear? Yes? Now this question, 17th question. 2n factorial can be written as, okay? So 2n factorial. You know that for anything it is written as 1 into 2 into 3 into so much into n, okay? Into n plus 1 into n plus 2 into 2n, right? 2n factorial is nothing but 1 into 2 into 3 into, no? For any n factorial as we write, so same thing like this. Now what happens here is, what do? I write down the even terms together, I write down the odd terms together, okay? We're just rearranging, okay? So I will write down rearranging. Two n factorial can be written as 2 into 4 into 6 into 8 into so on. And then I will write down all the odd terms. These are all the even terms, and odd terms will be 1 into 3 into, like this is up to 2n, and this is 1 into 3 into 5 into so on, right? So what do I do here is, until where will I go? Because this is 2n. Before 2n, what do I have? 2n minus 1, right? Before 2n, I have one number less, because before 3, I have 2. 2 is what? 3 minus 1. So here last term is what? 2n. What is the term before it? 2n minus 1. 2n minus 1 will be the odd term, because 2n is a even term. 2n minus 1 will be the odd term. So 1, 2, 3 into 2n minus 1. Okay. This is simply the rearrangement. So what will happen here? What is the common thing from here to here? 2 is common. So I will write down 2. What is going to remain? 1 into 2 into 3 into so on into n, right? I have taken 2 common here. But this is a multiplication sign. So how many 2's can I take out common? 1, 2, 3. How many? Up to n. So this is 2 raised to n common. Okay. You have to remember here that this is, because this is multiplication, I will be taking 2 raised to n common. From this I take 1, 2. From this I take another 2. Okay. And so I get this. Now I consider this. So what is this? This is already given in this bracket. So into 1 into 3 into 5 into so on up to 2n minus 1. So I have, now this is what? This is 2 raised to n. Now what is 1 into 2 into 3 up to n? This is nothing but n factorial. And what do I have remaining? 1 into 3 into 5. Okay. Into up to 2n minus 1. Okay. So A is the correct option. I hope you've understood. Okay. Yes, Lakshmi, you are correct. Right. Okay. So next sum that to take up is, okay, this is an interesting sum. So number of even numbers greater than 300 can be formed with digits 1, 2, 3, 4, 5. So how many numbers can you form? Some numbers will be 3-digit numbers, some numbers will be 4, and some will be 5. Okay. So because in this sum they have not mentioned whether the number is 4-digit, 5-digit, so I have to consider everything. Usually they will give you how many 5-digit numbers can you form greater than this. In this question they have not given you that way. They have just asked you to find the numbers which are greater than 300, but those numbers have to be even numbers. So let us see 3-digit numbers first. So 1, 2 and 3. For a 3-digit number to be even, what can be the last numbers? It can be 2 or 4. Okay. Because the numbers given are 1, 2, 3, 4, 5. Only from these given numbers can I use. So this is 2 or 4. So let last number be 2. So what will happen? This will be dash, dash and 2. So out of 5 numbers, 1 number is gone. Remaining 4 numbers are there. So what are the numbers available? 1, 3, 4, 5. What is the condition? Condition is saying that the number has to be greater than 300. So can I have 1 in the hundreds place? No. I can only choose from these 3. So in this, what will happen? In the first position, I can choose between any of these 3 numbers, 3, 4 and 5. Then what will happen in this place? I can have 1 here. So 1, 2 and 3. So 3. And what is the last space? It is already 1. So how many numbers are there? 9. Okay, so there are 9 numbers which are greater than 300 and which are even. Now what happens if the last number is 4? So dash, dash and 4. So 4 is already gone. What are the numbers remaining? 1, 2, 3 and 5. For the number to be greater than 300, can I have 1 here? No. Can I have 2 in the hundreds place? No. What are the numbers available? 3 and 5. So in this case, I have only 2 numbers from which I can choose. What happens in the next place? I have 1, 2 and 3. I can choose 1 also, 2 also. So I can have 3. So how many numbers are there? 6. Now 4-digit numbers. All 4-digit numbers will be greater than 300. Okay, I don't have a problem, but I need to have them as even. So 1, 2 and 3 and 4. Which are the numbers here? 2 or 4? So I have an option of 2. So out of this 5, 1 number is gone. So I have remaining 4. So this is 4 into 3 into 2 into 2. So 4 3s are 12, 12 4s are 48. So I have 48 4-digit numbers which are greater than 300 and which are even. Okay, so are even and greater than 300. Okay. Similarly, for 5-digit number 1, 2, 3, 4, 5. What will be the last number? 2 or 4? So I have a choice. So there are 2 numbers I can choose from. First position, 1 number is already gone. So how many I have? 4, then 3, then 2, and then 1. So this is again how much? This is also equal to 48. So I will just add them up. So this will be 9 plus 6 plus 48 plus 48. How much is this? 9 plus 6 plus 48 plus 48. Answer is 111. What option is there? C option is the correct option. Okay. I'm taking this fast because we already run out of time. Now this question, 19th question, please pay attention, very easy. 5 letters are written and there are 5 letter boxes. The number of ways the letters can be dropped in this boxes is 5 factorial. 5 factorial is how much? 120. Okay. Now this question, 20. NC1 plus NC2. Here we are relying on the property that combinations of n different things taken some or all at a time are given by 2n minus 1. Okay, so you can read the explanation. The explanation is given on page number 5.20. So you can read that. Okay. Akashleen, this is a very good sum that you've asked. So I will just solve this last sum over here. Okay, so here I have summation r going from 1 to 10 r into rpr. They are asking you to find the summation of this. So let me put it this way. So if I put r is equal to 1, what will I get? So this is 1 p1 plus 3p3 and so on. Okay, up to 10 into 10p10. Now how much is this? 1 into 1 factorial. 1 minus 1 is 0. Okay, so 0 factorial is 1 plus 2 into, again, what do I get? 2p2. So this is 2 factorial upon 2 minus 2. So 0 factorial. So plus 3 into 3 factorial upon 0 factorial and so on. So plus 10 into 10 factorial. 10 into 10 factorial upon 0 factorial. So how much do I get? This is 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial and so on plus 10 into 10 factorial. Okay. Now here what I can write is 1, I can write it as 2 minus 1 into 1 factorial. 2 I can write it as 3 minus 1 into 2 factorial. 3 I can write it as 4 minus 1 into 3 factorial and so on. And 10 I can write it as 11 minus 1 into 10 factorial. Okay. This is the most important step. I'm writing 1 as 2 minus 1. 2 I'm writing as 3 minus 1. 3 I'm writing as 4 minus 1. So what do I get here? This is 2 into 1 factorial minus 1 factorial plus 3 into 2 factorial minus 2 factorial plus 4 into 3 factorial minus 3 factorial. Okay. So like this I go on. So what do I do here? What am I getting here? This is 2 minus 1 into 1 factorial. This is 3 into 2 factorial minus 2 factorial and so on. And this will become plus 11 into 10 factorial. 11 into 10 factorial minus 10 factorial, right? So 2 into 1 factorial in minus 1 and 3 into 2 factorial minus 2 factorial and so on. What will I get over here? Now here, as you can see, 11 into 10 factorial is, you are getting what? 11 factorial. 4 into 3 factorial getting as 4 factorial. 3 into 2 we will getting as 3 factorial. And what will happen? For the others, they will cancel out. So what am I left with? Because this is what? 2 minus 1. So you will get 1 over here. So this becomes equal to 11p11 minus 1. Okay. So once you, because we are running out of time, otherwise I would have shown you how each of these numbers get cancelled out. Okay, so that is all. Yeah. In this 5.08 exercise A also, here, okay, this sum I just want to highlight that once, if you do it by substitution, you take the options, you substitute, this is going to satisfy this condition. तो जल्दी में आप उसको करेक्ट आंसर मत बोल दीजिए, because this numbers m is equal to 6 and n is equal to 2 does not satisfy the second condition. You have to take the second option, m is equal to 7 and n is equal to 1 satisfies both this, both the condition, mpn, m plus n p2 and m minus n p2. Because this satisfies both, this is the correct option. Okay, so be very careful. Just because 6 and 2 is satisfying this first condition, don't jump to the conclusion. Always put it in the second one also. Okay, right? I hope this solves all your doubts relating to permutation and combination. Yes, very good, very good. Yes, Mayur. Dipanshi. Yes, yes, Dipanshi. Okay. Thank you all for your patient hearing. Have a great evening ahead. Okay. Thank you.